Grace and peace to you all, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Okay, so today's question, we are still on gamma functions. Show that gamma of 1 over 2 minus n multiplied by gamma of 1 over 2 plus n is equal to the product of minus 1 to the power n and pi. Okay, so we can see that since there is a product of two gamma functions, we'll try to see if this is related to infinite product definition or Weierstrass definition. So first thing, we are going to let the expression here to be just a single variable. Okay, so solution. So we let's say m is equal to 1 over 2 minus n, 1 over 2 minus n. So if this is related to infinite product definition, it means if this is m, then this should be 1 minus m. So let's see if 1 minus m is going to give us half plus n. Okay, so let's see, 1 minus m is equal to, so we are going to have 1 minus m is 1 over 2 minus n. Okay, so this is equal to 1 minus multiplied by half, you get minus half, minus multiplied by minus n, you get plus n. Okay, so 1 minus half, you get half, then this is plus n. So we can see that 1 minus m is equal to half plus n, which is here. So this is related to infinite product or Weierstrass definition. So this is, so we just substitute where there is 1 over 2 minus n, you put m. So we are going to have gamma of m multiplied by gamma of 1 over 2 plus n is just 1 minus m. So 1 minus m. Okay, at this stage, I believe you remember that the infinite product definition is equal to, it's just pi over sine of, the letter here is m, so sine of m pi. Okay, so this is equal to pi over sine of m pi. Okay, and we know that m is 1 over 2 minus m. So where there is m, we are putting 1 over 2 minus n. Okay, so again this is equal to pi over sine of m is 1 over 2 minus n. So half multiplied by pi, you get pi over 2. Then minus pi multiplied by n, you get n pi. Okay, and I believe you remember that in trigonometry, when you have sine of a minus b, this is equal to sine a cos b minus cos a sine b. Okay, so we substitute where there is a is half pi over 2, and where there is b is n pi. Okay, so this will give us pi over sine of pi over 2 cos n pi minus, we are going to have cos of pi over 2 sine of n pi, sine of n pi. Okay, so we can work out this further of equals pi over sine of pi over 2. Sine of pi over 2, this is just 1. I believe you remember from special angles. Sine of 90, that's pi over 2, is just 1. So where the sine over 2, sine of pi over 2 is just a 1. Then cos of n pi. Cos of n pi. So the cos of a multiple of pi, this one is always a minus 1 to the power n. So depending with the value of n. Okay, so it can be a positive 1 or a negative 1. So where there is cos of n pi, this one is just a minus 1 to the power n. Okay, minus. Then cos of pi over 2. Cos of 90 degrees is just a 0. So this one is 0. Okay. Sine of n pi. Sine of n pi. Again, this one. The sine of a multiple of pi is always a 0. So this one is also 0. Okay. So we are going to have this is equal to pi over 1. It's just can just get rid of it. So we're going to have minus 1 to the power n. This is just 0. So over minus 1 to the power n. Okay. So now we want to show that gamma of 1 over 2 minus n and gamma of 1 over 2 plus n is equal to this minus 1 to the power n multiplied by pi. Not this, so we are not done yet. So what we can do is, for us to have something like this, we can see that on the numerator we're supposed to have minus 1 to the power n. Okay, so what we do to the numerator is what we do to the denominator, so that we don't change the value of the value of an expression. Okay, so we are going to multiply to both the numerator and the denominator minus 1 to the power n. So we'll multiply minus 1 to the power n to the numerator as well as to the denominator. Okay, so this is equal to pi multiplied by minus 1 to the power n. We'll get minus 1 to the power n multiplied by pi over here we have minus 1 to the power n multiplied by minus 1 to the power n. So since we have same bases, we are going to add just the powers. So we are going to have minus 1 to the power n plus 1, that is 2n. And we know that minus 1 to the power 2n. 2n is an even number. So if you raise a negative number with an even power, then it will be positive. So minus 1 raised to an even power, you get a 1, which is positive, a positive 1. So this will be minus 1 to the power n multiplied by pi over, this is just 1. And 1 in this term, you get this same term. So this is equal to minus 1 to the power n pi. This is what we have. So hence shown.